Hello all, welcome back. So in this today's class we are trying to design the we'll try to design how to implement the MOD-6 asynchronous counter using JK flip-flop, right? So if J equal to 1, K equal to 1 connected, then we can use the JK flip-flop. But if you want to use the T flip-flop, means just we'll connect the T equal to 1. That is only the different when you are using JK flip-flop or T flip-flop. That point you have to remember, because the next question is something like this: design MOD-6 asynchronous counter using T flip-flop, right? Now see that what is the meaning of MOD-6. MOD-6 means 6 count, right? So what is the starting count value? If you see that, if you are writing the first state diagram, right, so what is the first count value? 0 0 0 0 0 1 0 1 0 0 1 1, next 1 0 0 1 0 1. So 6 count means 1 2 3 4 5 6. It means that first, after changing the clock pulse, it should change from 0 to 1, then 1 to 2, 2 to 3, 3 to 4, 4 to 5. It means that MOD-6 means 6 stages. 0 is the starting state, 5 is the ending state. It means 0 0 0 is the starting state, 1 0 1 5 is the ending state. So that you will be getting the 6 stages or 6 count. Now after here, if you observe here, after 1 0 1 we should get the output as the 0 0 0 0. This is the requirement we need to design. So before that, what is the meaning of MOD-6? 6 stages, right? So 6 count means, right, how many flip-flops are required? If you take the 2 flip-flop, then we can able to get the only 4 counts, right? But if you want to count the 6 counts, then how many bit representation we have? 3 bit representation we have. So 3 bit means how many flip-flops are required? 3 flip-flop required. So which flip-flop we need to use? We need to use the JK flip-flop operation, right? So how many flip-flops we require? 3 flip-flop. Remember that point. Now one more important point to remember here is, so how many flip-flops here we are considering? 3 flip-flop, right? So 3 flip-flop means, suppose if I say something like this, I'm considering the 3 bit, 3 bit means 3 flip-flop. What is the count value? 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1, next 1 1 0 1 1. If we take 3 bits, how many counts by default we will be getting? It means that if you are considering the 3 input value, by default we will be getting the 8 counts value. But out of this 8 counts value, what is our requirement? We required only 6 count. It means that once 1 0 1 is completed, it should return back to the initial position. But what is the problem here is, if you observe here, as we are considering the 3 bit information, as usual it will produce the 8 bit possibility, right? It means that it will produce the 110 as well as the 111 also. But these things should not be occur. But if you take 3 bit value, this also will occur. Now question is that how to avoid this one? Then it will become the MOD-6 counter. It means that if you observe here, so MOD-6 means 1 2 3 4 5 6, right? So this is what we required, right? So this we don't require, right? Now what we have to do is, somehow if we take the 3 bit information, obviously you will be getting the 8 counts value, but we required only 6 count value. It means that if you observe this table, which one we should terminate? Before occurring this, which one we should terminate? It means that one count is reaches to 101, then again it should return back to the initial position. But as per the 3 bit means, after 101, what is the expected count? 110, it should not come. It means that, so which one we need to stop? 110 we need to stop. See, if you stop 110, what will be happen? 111 will not come, right? The moment if you stop occurring of 110, it means that we are making every value in the flip-flop is 0 0. It means what we are doing, stopping. So stopping means again it will return back to the initial position. Again you will be counting the 0 1 2 3 4 5. Again it will go here. Again you will be counting the 0 1 2 3 4 5. Now if you understand this one, what is the things which should not be occur? It should not come to the 110, right? It means that we should stop this occurring of the 110. If you stop this one, it means that whenever it detects the 110, you just make the all the flip-flop value is 0 0. You make reset the 0 0, so that again it will start from the 0 1 2 3 4 5. Before, if it is detecting the 6, you just stop it. So again it will start from again 0 1 2 3 4 5. So this is how we need to design the MOD-6 counter. If it is MOD-8, it is okay, no problem, nothing will be happen. But MOD-6 means here we will be getting the problem. This need to be stopped. It means that after 101, it should not be occurring of the 110, right? If 110 is not coming, it will not go to 11, right? If 110 is coming, then only we will go to 11, right? Then we will go to 00, right? Now we are stopping this one. The moment you stop this one, it means that it will go to here, right? So this is what you have to remember here is, right? So which should not be occur? This 110 should not be occur, right? So 5, 101 means 5. This is the final count. So how many flip-flops are required? As we discussed, the 3 flip-flops are required, right? So in case of JK flip-flop means just we are connecting TA equal to 1. In case of JK flip-flop means just we are connecting J equal to 1, K equal to 1. That is only the difference in circuit diagram. Remaining everything will be same only, right? So now how many flip-flops are required? 3 flip-flops, right? So just I am taking the 1, 2, 3 flip-flops, simple. Right, so for understanding purpose, I am naming it as the A, B, C. So inputs are what? JA, KA. For the second flip-flop, inputs are JB, KB. For the third flip-flop, inputs are JC, KC. So outputs for the first flip-flop is QA, QA bar. Here QB, QB bar. Here QC, QC bar. So again we have the clock pulse, right, along with the inputs. Now what is this type of the counter? Asynchronous. Asynchronous means first flip-flop will be triggered by the external clock pulse. The output of the remaining flip-flop will be given to the clock pulse for the next flip-flops. Now one more condition, that if you want to perform the toggle operation changing 0 to 1 or 1 to 0, in which flip-flop it is possible? JK flip-flop. In which condition? JK flip-flop, it will perform the toggling operation when J equal to 1, K equal to 1. So again we need to connect J equal to 1, K equal to 1. For second flip-flop also JB, KB should be 1, right? For third flip-flop JC, KC should be 1, right? It means that instead of giving the 3 individual ones, if I just connect here, it means that the moment if we enter here 1, JKA 1, JBKB 1, JCKC 1, so that number will be changed from 0 to 1 or 1 to 0, so that you will be getting the up counting or down counting operation. Right? Now if you observe this circuit diagram, is it MOD-6 counter or MOD-8 counter? Try to pause the video and find the answer. What is this one? MOD-6 or MOD-8? This is the counter which we designed for the MOD-8. Now what we have to do? By default it will count the value from 000, 001, 010, 011, 101, next 110, 111. But what is our requirement? Once it reaches to the 101, again it should go back to the 000, right? It means that after 101, what should not be occur? 110 should not be occur. If 110 is not occurring, right, it means that 1111 will also not occur, right? So now what is the stop we have to do is for 110 we are going to perform the stop operation. So what do you mean by this? How we can able to find out the answer in easiest way is, this is one logic you can remember. So first flip-flop value is QA, second flip-flop value is QB, third flip-flop value is QC, right? So always LSB, MSB like that only we need to take, as the logic we have explained in the previous class. Don't try to take something QA, QB, QC, right? So just take first LSB, next bit, next bit. First flip-flop will be always QA, next QB, next QC. So which count we should stop? 110, right? So 110 should be stopped. So what do you mean by this? The moment whenever it detects in the 110, what should be the flip-flop value? 000, right? So ante 110 should not come, right? If before it is coming, after 101 it should be 00. Ante what I am trying to do here is, somehow I need to make this value as the 000, right? It means that what is the operation we are performing? We are performing the clear operation. After performing the clear operation, what will be happen? The count will back to the 0, 1, 2, 3, 4, 5. The moment it detects this count, automatically it will reset the flip-flop value into the 000. So for that, what I am doing means, once the count is detected, now what we have to do is, we need to make this flip-flop 1 value, 2 value, 3 value as the 00, right? So for that I am going to consider some extra mechanism called as the clear pin operation, right? So here I am going to take the clear pin operation. Clear pin bar means whenever it detects the 0, it will make all the flip-flop value equal to 0, something like this. Whenever it detects the output 0, it will make all the flip-flop value will be 0, 0, 0. Now see that this condition should not be occur, right? If this condition is occurring, what we have to do? We need to reset the flip-flop value is what? 0, 0, 0, right? So it means that, see that this is already 0, right? This is already what, 0, right? Now what we have to do, this QB value, QC value is 1 1, right? This we should change as a 0 0, right? See, this is already 0, no need to do any modification. Where we need to perform the modification, QB value should be set to the 0, QC value should be set to the 0. That's what we have to do. If you do something like this, then always you will be getting the value will be 0 0. Remember, QC should be 1, QB should be 1. This is not required. Why? Because it is already 0 only. Now if you observe, so when it will be clear the value of this value, this value, this value, whenever it detects the clear bar value equal to 0, right? Now what is this QC value? QB value, right? If 1 1 means what will be happen? If your QC value, QB value 1 1 means what will be happen? Just I am taking the NAND gate operation, right? 1 1 means what is the output value? 0, right? Whenever it detects the 0, what will be happen? The clear pin will activate the here 0, here 0, here 0, right? This is what. Now what is the QC? Where we have, here we have the QC, right? So just you connect here. Where we have the QB, so we have the QB here, so just connect to here, right? By using this external mechanism, instead of getting the 8 counts, we are getting only 6 count. Simple thing. Which one we need to start? 1 1 0. So QA, QB, QC. So here only we have the 1 1. So just you connect it to the NAND gate. Which one? QC, QB, so that the moment whenever it detects the 1 1, it will make the all the flip flop value will be 0 0 0, right? This is what we have to implement. Now if you see that you might be having the still doubt, right? Will this one will be reset? No. Why? So whenever it detects QC, QB equal to 1, then only it is going for reset operation, right? Now if you see that here no QC, QB 1 1, right? Ikkada 1 1 ledu, here also we don't have 1 1, here also we don't have 1 1, here also we don't have 1 1, here also we don't have 1 1. It means here only it will perform the resetting operation, right? Now the given question is something like this, using JK flip flop on and unco, right? This is a procedure. If the given question is something using T flip flop on and unco, now how to do this one? Simple thing, only instead of JAKA, just here we need to take TA, TB, TC, that we should connect it to 1. That's the only thing, right? So remaining everything will be pretty same.